Picture this: a quiet night, the stars above twinkling like they always have, steady and familiar. Then, out of nowhere, a stranger streaks across the sky, moving faster than anything we've ever seen, 60 kilometers per second, tearing through the vast emptiness of space. It's not just any space rock, it's 3I/ATLAS, the third interstellar object ever spotted in our solar system, a visitor from a place so far away we can't even imagine it. This isn't just a cosmic curiosity, it's a mystery that's shaking the foundations of what we think we know about the universe. And when someone like Bill Nye steps up to issue a serious warning, saying this thing's recent shift in course could mean hidden risks, you can't help but feel a chill. What is this object, and why does it feel like it's trying to tell us something? Let's step back and breathe in the wonder of this moment. Our solar system is like a sleepy neighborhood, orbiting the sun in a predictable dance. Planets, asteroids, comets, they all follow the rules, bound by the sun's gravity. But 3I/ATLAS, it doesn't care about our rules. It's an outsider, racing in from the depths of the unknown, carrying secrets from a place beyond our reach. Scientists first spotted it hurtling toward us, a faint blip on their telescopes, moving in a way that screamed it wasn't born here. It's only the third of its kind we've ever confirmed, following ʻOumuamua and Borisov. But this one's different. It's not just passing through, it's rewriting the story of the cosmos with every move it makes. Why does this feel so big? Because 3I/ATLAS isn't acting like anything we've studied before. The headlines call it a space rock, but that's like calling a symphony a single note. It's doing things that don't make sense, things that make astronomers double-check their instruments and whisper to each other late at night. The chemical enigma that's got scientists scratching their heads. When you think of comets, you picture icy giants, right? Chunks of frozen water and dust, maybe some carbon dioxide, tumbling through space, leaving a glowing tail as the sun warms them up. That's Comets 101. Water is always the star of the show, the main ingredient in every comet we've ever studied. But 3I/ATLAS, it's breaking all the rules. Its surface is pumping out carbon dioxide at a ratio of 8 parts to every 1 part water. 8 to 1, held steady within a fraction of a percent since we started watching it. That's not just unusual. It's like finding a car that runs on orange juice instead of gas. It shouldn't work. Natural processes don't do this. They're messy, they fluctuate, they shift with the environment. But this thing? It's steady as a heartbeat, precise in a way that feels almost unnatural. And then there's the nickel. Oh, the nickel. This is where things get really wild. 3I/ATLAS is flinging pure nickel vapor into space. 99.97% pure, cleaner than anything we find in nature or even produce in our most advanced labs on Earth. In space, metals don't behave like this. When they heat up, they come mixed with other elements like iron, because that's how the universe works. Separating them takes massive energy, like the kind we use in industrial furnaces here on Earth. But out there, in the freezing void of space, 3I/ATLAS is doing it on its own, spitting out nickel so pure it's like it's been refined by some cosmic machine. And it's not random. The nickel comes in bursts, exactly 17.5 minutes of intense outflow, followed by 42.3 minutes of quiet, like clockwork. Over and over, with computer-like precision. Natural comets don't do that. They pulse irregularly, driven by the sun's heat. This feels like something else entirely. Imagine standing in a lab, watching a machine churn out perfect polished metal, timed to the second. Now picture that happening on a rock hurtling through space, with no visible power source, no nuclear glow, no solar panels, nothing to explain where this energy is coming from. It's enough to make your heart skip a beat. Scientists are calling it unusual but not unprecedented. But let's be real. There's no precedent for this. No comet, no asteroid, no object in the history of astronomy has ever shown this combination of traits. The nickel alone should have the world's top minds gathering in emergency meetings, but instead, we get carefully worded statements that downplay the weirdness. Why? Are they afraid to admit they're staring at something that might change everything? Let's linger on that nickel for a moment, because it's not just what it's doing, it's how it's doing it. Spectroscopic data, the kind that lets us peek at the chemical fingerprints of objects in space, shows something even stranger. The nickel particles aren't just floating away like dust in the wind. At about 10,000 kilometers from 3I/ATLAS, they're arranging themselves into patterns, geometric shapes, almost like tiny structures forming in the void. This isn't random debris scattering. It's organized, deliberate, like the kind of self-assembling materials we're only just starting to dream up in labs on Earth. Some scientists, quietly behind closed doors, are whispering about molecular manufacturing, materials that build themselves into predetermined shapes. If that's what's happening, it's a process so advanced it makes our technology look like child's play. Even the most mundane explanation, some exotic natural process we've never seen, is mind-blowing. I/ATLAS, as it carves its way through our solar system, moving like nothing we've ever seen before. This isn't just a rock tumbling through space. It's a traveler on a path so precise, so improbable, it feels like it's dancing to a tune we can't hear. Picture it, an object from beyond our stars, racing at 60 kilometers per second, moving backwards against the flow of our planets, yet somehow weaving past Venus, Mars, and Jupiter with a precision that makes your heart race. The odds of this happening by chance? A staggering 0.005%. That's not just unlikely. It's like shuffling a deck of cards and getting them in perfect order, every suit lined up, every number in sequence. It's the kind of thing that makes you wonder, is this luck, or is something guiding this cosmic visitor? Let's walk through its journey, step by step, and feel the weight of what's unfolding. In September 2025, 3I/ATLAS will glide within 0.08 astronomical units of Venus, close enough for our telescopes to catch every detail, but far enough to slip by without a hitch. Then, in November, it swings by Mars, hitting that same sweet spot, perfect for us to watch from Earth. And in January 2026, it meets Jupiter, completing this trio of flybys, each one lined up just right, as if it wants us to see it. Here's the kicker. All these planets are on our side of the sun during these moments, lit up for our instruments to study. If they happened on the far side, we'd miss the show entirely. Coincidence? Maybe. But when every piece falls into place like this, it starts to feel like a pattern, a story written in the stars that we're only just beginning to read. What makes this path so jaw-dropping is how it defies everything we know about space. Objects moving this fast through a planetary system usually get yanked around by gravity, slingshotted into unpredictable arcs when they pass near planets. But 3I/ATLAS, it barely budges. It's like a bullet weaving between raindrops, holding its course with only the tiniest nudges from Venus, Mars, and Jupiter. Planetary defense experts, the ones who track asteroids to keep Earth safe, are scratching their heads. Their models, built to predict how objects move through our system, fall apart when they try to map this thing. It's not just that it's fast, it's that it's steady, unshaken, as if it's following a map we can't see. Something about its mass, its makeup, or, dare we say it, its ability to adjust its course doesn't fit any natural pattern we've ever studied. Let's pause and let that sink in. The odds of a random interstellar object threading this cosmic needle, hitting these exact flybys with such precision, are so small they're practically impossible. To put it in perspective, you're more likely to win the lottery twice in a row than for an object to pull this off by chance. Scientists are calling it a statistical anomaly, but that feels like a polite way of saying they're stumped. The math doesn't lie. A 0.005% probability means this shouldn't happen, not in 1,000 years of watching the sky. And yet, here it is, moving with a grace that feels almost intentional, like it's meant to be seen, meant to be studied, meant to make us question everything. There's another layer to this that sends shivers down the spine. The way 3I/ATLAS entered our solar system is just as strange as its path through it. Most interstellar objects, if they come at all, should drift in along the galactic plane. That's where the stars, the dust, the stuff of the universe tends to hang out. But 3I/ATLAS? It dove in from above, almost perpendicular to that plane, at a 90-degree angle that's wildly inefficient for a natural object. It's like it fought against the galaxy's gravity to take this route, a path that gives it a front-row seat to our entire planetary system. It's not just passing through, it's surveying, taking the scenic route through our cosmic backyard. Another coincidence? At some point, you have to wonder when coincidences stop being random and start feeling like purpose. This path, this precision, it stirs something deep inside. It's the kind of thing that makes you look up at the night sky and feel small, but also alive with curiosity. What's driving this object? Why is it here, threading its way past our planets like it's on a mission? Scientists are cautious, sticking to phrases like, "we need more data," but behind the scenes, they're wrestling with the same questions. The trajectory alone is enough to make you feel like we're on the edge of something huge, something that could change how we see our place in the universe. But this is only part of the story. There's more to 3I/ATLAS, whispers of signals, behaviors that defy physics, clues that no one's ready to shout from the rooftops just yet. Imagine this for a moment. You're an astronomer, staring at data that doesn't add up, feeling the weight of something extraordinary, but knowing the world might not be ready to hear it. That's where we're at with 3I/ATLAS. It's not just a visitor, it's a challenge, a mystery that's pulling us toward the unknown. As it continues its journey, every move it makes feels like a piece of a puzzle we're only starting to grasp. Hold on to that sense of wonder, because the next part of this story is going to take us even deeper, into signals that don't belong, dust that moves on its own, and a temperature that defies the cold of space. We're not done yet. This is just the beginning of what 3I/ATLAS might reveal. Now, let's step into the shadows of this cosmic mystery, where the whispers grow louder and the questions cut deeper. 3I/ATLAS isn't just breaking the rules with its chemistry or its path. It's leaving clues that feel like secrets meant to be found, yet too strange for anyone to say out loud. Picture this: astronomers huddled around their screens, picking up faint signals from the void, seeing dust move in ways it shouldn't, and watching a temperature that refuses to make sense. These are the pieces of the puzzle no one's shouting about, but they're the ones that make your heart pound, wondering what's really out there. This is where 3I/ATLAS stops being just a space rock and starts feeling like a story we're not ready to hear. Let's start with those signals. Faint, ghostly hums in the radio static, picked up by 3 separate listening stations pointed at 3I/ATLAS. These aren't random bursts of cosmic noise. They're structured, patterned, unlike any natural emission we've ever recorded. Imagine being at Green Bank Observatory, staring at your equipment, checking it twice, 3 times, because the data says something's coming from that object. Something that doesn't match the hum of stars or the crackle of gas clouds. No one's calling it communication. That's a step too far, too risky. The official line? Instrument glitches. But when multiple telescopes across different locations keep hearing the same thing, that excuse starts to crumble. These signals are like whispers from a room you're not supposed to enter, and they're making scientists nervous, not because of what they prove, but because of what they might mean. Then there's the dust. You'd think dust around a comet would be simple. Tiny particles blown back by the sun's radiation, forming a glowing tail we all know from pictures. But 3I/ATLAS is doing something else entirely. High-resolution images from the James Webb Telescope show its dust arranging into layers, like the rings of an onion, orderly and precise. Some of these particles are even moving against the solar wind, defying the push of radiation that should scatter them. It's as if they're alive, guided by invisible forces, maybe magnetic fields that shouldn't exist, or something stranger, something self-propelled. Scientists studying this won't go on record. They can't explain it with the physics we know, and no one wants to be the first to suggest the impossible. But when you see dust dancing in patterns that shouldn't be possible, it feels like the universe is nudging you, daring you to ask questions you're afraid to voice. And then there's the temperature, another piece that doesn't fit. 3I/ATLAS is holding steady at 250 Kelvin, about minus 23 degrees Celsius, no matter how far it gets from the sun. At its current distance, it should be colder, closer to minus 100 degrees Celsius, frozen in the chill of space. But it's not. Something's keeping it warm, either generating heat from within or handling solar energy in ways we can't explain. No nuclear reactions, no visible solar collectors, nothing that accounts for this steady warmth. Scientists at NASA's Jet Propulsion Laboratory are checking their instruments over and over because these readings break the rules of thermodynamics in space. It's like finding a campfire burning in the middle of a blizzard, with no wood, no fuel, just flames that refuse to die. It's unsettling, and it's pushing people to the edge of what they're willing to believe. These clues, signals, dust, temperature, they're the kind of things that keep you awake at night, staring at the ceiling, wondering what we're missing. Behind closed doors, astronomers are having late-night talks, poring over data they can't explain, afraid to be the first to say what everyone's thinking. There's a tension here, a pull between the safety of saying we need more data and the thrill of admitting this could be something revolutionary. It's not just about 3I/ATLAS itself, it's about what it's forcing us to face. The universe is bigger, stranger, and more alive than we've ever imagined. And this object is like a key turning in a lock we didn't know existed. But let's step back and look at the bigger picture, because this isn't the first time we've seen something like this. History is full of hints, fleeting glimpses of visitors that didn't fit the mold. Back in 1844, the Great Comet puzzled astronomers with its odd movements, defying the neat orbits they expected. Old logbooks from the 19th century, now digitized, describe strange transients, objects that appeared and vanished, moving in ways that didn't make sense. Ancient Chinese records from the Song dynasty talk of guest stars that moved against the sky's rotation, just like 3I/ATLAS's backward dance. Medieval Islamic scholars noted wandering lights that didn't match planets or comets. Even Galileo scribbled about objects that blinked in and out of view too fast to be normal. We've dismissed these as mistakes or myths, but what if they weren't? What if our solar system has been hosting these travelers for centuries, and we're only now, with our telescopes and tech, starting to catch them in the act? Modern data backs this up. The Pan-STARRS telescope, which spotted ʻOumuamua, has seen dozens of faint objects with paths that scream interstellar, but they were too quick or dim to confirm. NASA's NEOWISE mission has caught infrared signatures that don't match anything in our solar system, filtered out because they don't meet the strict rules for publication. Even military radar has picked up fast-moving blips that vanish before anyone can study them. 3. I/ATLAS might not be rare. It might just be the one loud enough, big enough for us to notice. It's like we've been living in a house with visitors passing through, and we're only now learning to hear their footsteps. This is where the story of 3I/ATLAS becomes more than a mystery. It becomes a mirror. It's showing us how we react to the unknown, how we balance wonder with caution. Are we ready to chase these clues, to ask the big questions even if they scare us? Or will we cling to safe answers dismissing what doesn't fit? The signals, the dust, the heat, they're pieces of a puzzle that's bigger than one object. They're a call to look up, to listen, to wonder. As 3I/ATLAS keeps moving, it's not just carrying secrets from the stars. It's carrying a challenge, to face the unknown with courage, to let curiosity win over fear, and to keep searching for the truth no matter how strange it seems.